I will look to cover the key concepts and the evolution of enterprise application containerization. Then I will look to describe reasons for banking and telecom clients adopting enterprise application containerization. Then I will look to review 3 of the leading solutions in the market, followed by strategy for adoption. And then I will pass on the programs to able to do the evaluation of rancher. They will demonstrate rancher as much as possible, and then we'll open up for question and answers. So let's get started. Now let's just put some key concepts into the flow conversation. So what is containers and what are containers and what are they used for and how do they actually work? So containers effectively they are really used by developers to package an application. They are a packaging mechanism. What that means is, from a developer perspective, you are typically writing code and packaging that code in a form that allows you to deploy it in a much faster, in a much more faster way, but also allows you to evolve that platform for deploying it much quicker. All the dependencies are copied alongside and packaged into one main package, and that's what a container. A container should be seen as a logical packaging mechanism for hooking up software libraries and dependencies together and putting that into a production environment to work. There are 6 critical things you should know about container containerization. The first thing is, well, it's actually a methodology. Enterprise containerization is a methodology for deployment and execution of software. The second thing really is about the fact that enterprise application containerization or containerization is about operating system level virtualization method. It is about leveraging operating systems, but not necessarily leveraging virtual machines as it's already used in most organizations use, but it's packaging your software solution within what we're calling a container engine and deploying the binaries and apps on top of that, leveraging a containerization approach. And the third thing is about containers can operate on bare metal systems, on cloud infrastructure, and on virtual machines. So you can deploy a container within this kind of environment and have it run your workloads within that. So it's really a package mechanism to deploy and run with distributed application workloads. That's what a container is. Now, if you look at the diagram that I've got on the screen, I have to the left-hand side, basically what we already do in most cases, we have a virtual machine. What typically happens is on the physical computer, the whole operating system is installed. The hypervisor here is referring to a virtual machine at one side, and then you can have multiple virtual machines deployed on top of that. It was running the workload. But then the reality is that exercise involves putting an additional operating system, delivering your libraries, your code libraries, putting applications. So it's less efficient in terms of looking to take advantage of the physical infrastructure. With containerization, what we're really talking about is moving away from leveraging virtual machines, but actually leveraging a container, an operating system level virtualization technology, which is what containers are. And instead of having too many VMs, you have a container deploying multiple, so a container can hosting and managing multiple application containers that are deployed in that environment. So it's far more efficient than what's currently on the virtual machine. Now, of course, the container engines are the mechanism really in which you actually package a solution. And the most popular one, I'm sure most of you have heard about, is Docker. Docker in fact is actually a tool. It's a tool for creating and deploying the application components and packaging them into a containerized infrastructure. Docker is one technology you hear about around packaging utilizing applications. Containers effectively are fundamentally are built from 2 critical historic services. So microservices and DevOps are 2 kind of ways of actually modeling the systems that benefits a lot. That containerization and conventional benefits a lot from. So microservices is about deploying loosely services, loosely coupled services and applications. While DevOps is really about changing the culture of work environment to take advantage of developers and operators and operations teams working together to deploy applications much more efficiently and much more robust. So containerization really benefits from the activities and services around microservices and DevOps. Another thing about containerization is really about the solution is built on open source and is built on open source and open architecture, which means really that it's very acceptable and widely used in the industry. Specifically in the telecoms and the banking sector, there are lots of benefits that containerization offers. I'll be talking about that very briefly in this webinar. Now, what I've not mentioned so far is Kubernetes, which is another component that's very important. Kubernetes is really about sharing, managing the workloads of containers. The Kubernetes is effectively the technology that allows you to manage different workloads, how they actually work within the environment of your container engine. So I'll be talking a little bit about that. And what solution that effectively is what we'll talk about in this particular. So I'll come back to that in a few minutes. Now, going back to what's the value of enterprise application containerization? Well, it's really about a number of things. Companies are realizing that they need to offer superior operational services in very, very fast time scales, but they need to do it in a consistent and clear manner. So, and as we evolve into this world of cloud technologies, there is a real advantage in actually taking on board the fact that solutions have to be consistent and faster, and containerization is a mechanism to achieve that. There have been a number of initiatives. There's the Linux initiatives, which is built on, which basically the Linux Foundation is an open source, and there's been a number of initiatives of the Linux Foundation, especially for what they call the Cloud Native Computing Foundation. So, Cloud Native Computing Foundation really is a body really looking to introduce as more with flexibility and seamless integration and delivery of solutions within the cloud. So that organization is set up really to try and promote the values, some of the values that are important in ensuring that applications become very cloud native when they run in the cloud. Now, that cloud native solutions then therefore requires a number of technologies to work effectively. One, of course, is cloud. The second is leveraging very robust, fast technologies to deliver the offering. Kubernetes is definitely it's an open source platform really upon which you can automate the deployment of applications. And we're going to talk about that with the access to it. There are some key benefits about Kubernetes, which is around the fact that it's self-healing, which manages costs very effectively. It delivers very effective storage orchestration mechanism. It has a lot of services for them with balance capability, and it also needs to work with rollouts of applications. But what's the real value of enterprise application containerization? I think the way to look at it is around a number of things. It's about the suitability of the application and the capability you're looking to launch, and of course the efforts to deliver those applications and the cost of doing that. So if you take two applications, for example, product A, product B, suitability is considered to be 10. These are just examples. Capability that you're looking to launch is 10, but the installation effort is for product A is 10. And the cost of that is the calculation. You can see that from a calculation perspective, the value of actually leveraging that product A is diminished because of the fact that the cost of installation is so high. The ethical application containerization tries to do a lot better than that, tries to reduce the cost of installation, because that would be a detriment to actually leveraging the application, and of course increasing the value of the offering. So really, the enterprise application containerization helps to deliver a much more effective release cycle software within the environment, or actually within the cloud offering. But much of the world we try to describe how Rancher does that, how the Rancher supports the deployment of applications. And I'll do a check you'll see an example of how that goes. So turning to containerization, how did we get here? I'm first of all going to look at banking perspective. How did banks get to this mechanism? Well, if you look at what happened in early banking years, banking 1.0 was really around having solutions in place, just physical infrastructure. So most banks in the 60s and 70s operated had to do a head office. They used very limited mainframes. They used some people because mainframe and dump terminals. So there was very little value around building large-scale applications to support their needs. So many applications were on the mainframe, and so the needs were very limited. There was no need for thinking about leveraging more advanced solutions to support the workload that they need to manage. Banking 3.0 became more urgent in the 1980s to around 2007. And if you notice in that time, the tempo was still a very steep aspect. But you'll notice that we need to deploy servers, ACS were used, mobile applications were beginning to come up, and of course, PCs were beginning to be used. But there was less see that, at that time we started to begin to leverage effectively PCs and servers, and we were now beginning to deploy applications and operating systems and just applications on top of that operating system. So that's how it was pre-2008. So it was all very much applications were deployed, physical hardware, and we were happy to kind of work with that model. But we then started to evolve with what we call banking, which is about utility banking, where we were now beginning to move away from having lots of banking offices to having to deploy solutions leveraging the internet, or actually leveraging the internet for running banking offices. You will notice that utility 1.0 really is around that, ensuring that banking services can be deployed on cloud, can be leveraged with social media, mobile devices, and web applications were more popular. And as we began to move into that phase where we were beginning to deploy things more in the cloud, there was a need to actually have in place very robust mechanisms to support deployment of systems within the cloud and also within our on-premises solution. And that gave rise to the more hypervisors. So that virtual machines became prominent around 2007 to 2010. We tried to deploy virtual machines because we wanted to deploy more applications. But we didn't get a lot of benefits around that. We got three benefits in terms of, yes, we could stand up applications with virtual machines, but there wasn't an efficient way of actually deploying these applications. And then Docker, which is a containerization tool, was developed to kind of support how do we effectively deploy applications much quickly, much faster, and with less problems. That was where we gave rise to containerization as a platform. But of course, now we're in banking 4.0, where we're trying to do what we call banking anywhere, anytime. We're now getting to a point now that utility banking is really where we're going now. And we need to start to deploy applications much more quickly with customers, partners, relationships, demand that software solutions that are put out actually and done at very much quicker. So we're now at banking 4.0, and it's now evident that Kubernetes is really a really good value to help deliver these kind of services much quicker to customers. Now, if you look at what's happening also in the telecom sector, that also gave rise to the similar type of thing. In the telecom sector, telecoms have always operated to go from 1G, 2G, 3G, to 4G, and 5G. At 1G, most telecoms operators operated in analog phase, so they were very limited for hardware or software solutions that would drive their business. But if you look at where we are now with 4G and 5G networks, applications, telecom operators are realizing that there's real value around leveraging applications. And that gives rise to cloud native applications that are now effectively need to be deployed on much more effective and leveraging Kubernetes. So really, the change in the industry, the change in the market is dictating the move to begin to do solutions at a much faster rate, leveraging applications as a service. So why should we adopt Kubernetes? I think the key thing really is around, from a banking perspective, around value. Banks are recognizing the operations of the view that they need to really kind of deliver quick things to customers. They need to be able to acquire customers quicker, they need to retain them, and they need to create the right experience for customers. Applications are vital to make that happen for any customer, for any bank. So they're beginning to realize that that's the most thing they need to focus on. And they're spending their money on that. And on the crux of that is the fact that even though they're looking to deliver that value, the maturity of the technology landscape has also enabled them to do that. So containers, digital services, that are really things the banks are able to leverage now to deliver that customer experience. If you look at what banks actually have to have, if you look at what they were doing in 2019, the banks were looking to acquire customers. If you look at any bank, they were looking to spend their money on acquiring customers. They were trying to kind of create cross-sell solutions and deliver new products and services. That's what they were looking to spend their money on. And if you look at those solutions, they all underpinned by software. Software drives the value around new customer acquisition, around loans, mobile applications, self-service. So when they're looking to deliver all those things, they need to have software. And the ability to deliver the software quickly on a reliable platform is vital to the bank. So really, it's one of the mechanisms that these banks can deliver value to their customers, shareholders, very quickly, because of course the whole process of creating deploying software is automated and deliver more efficiently. value that banks need to kind of focus on. And of course, the technology is right around, they are looking to leverage DevOps and integration. But most banks have begun to operate on a DevOps and integration model. They recognize the need for speed and agility in their operations. They also install customers. From a customer perspective, they want to know that customers want things to be done quickly and change the software they use to become much more resilient. So they're looking for systems that help them maintain that. So we're in a perfect situation for banks to begin to leverage this technology to drive the value that we see. The same thing applies if you look at what is going on in telecoms. In the next few years, all telecom organizations will start with design. What that really means is that applications that are going to be used by telecoms would really need to be very, very scalable and efficient in how it works. And they want to utilize the infrastructure well. The days are long gone. The telecom clients, telecom organizations are looking to deploy more hardware, looking to kind of leverage cloud functions on infrastructure. So they're looking to move away from physical infrastructure to deploying applications on speed leveraging software. So doing that, there are critical things of telecom that they are recognizing. They are driving towards a 5G core infrastructure, and they recognize that they need to move from physical infrastructure. So they move from the left to the right, so software defined network, which we were doing years ago, to network functioning virtualization, which is where they're now, and they're looking to move to cloud native apps. And cloud native apps and network virtualization all can be delivered on this directed virtualization model. And that's really the driving force. So telecoms will get a lot of value in looking to adopt Kubernetes or virtualization within the operation. If you look at cloud native, which is the drivers around some of the things they're trying to do, containers are typical technology to provide that. Foundations such as CNCF, those I talked about very quickly, are also very much keen in helping them to achieve that. And of course, apps are now the way forward. They're looking to leverage most of the compute, storage, networking facilities with software rather than hardware. And containerization is the next few years. Okay, so I was just basically describing that containerization, the reason for adoption really is around speed and agility. So any telecoms operator or banking operator is looking to launch applications much quicker than where they were a few years back. And of course, efficiency is really what's driving it. They're trying to kind of create applications that will help them achieve the kind of market agenda they have, and also ensuring that they're utilizing the infrastructure more efficiently. So speed and agility is really just one of the drivers to kind of benefit from enterprise modernization. In the banking sector, there are threats around the uncertainty markets, the COVID-19 situation, but also fintech are taking share in the market of banking clients. So they need to have the applications put out more rigorously, more quickly, and more consistently in a manner that they can effectively deliver value to customers and shareholders. So there are really a lot of good reasons to adopt modernization. And to do that effectively, there are certain strategies that most organizations in banking and telecom realize. They realize that the cloud-first strategy is paramount to be able to drive value going forward. They know that DevOps is a mechanism that will really help them to deliver things, operations and development activities in the different culture in terms of a more progressive and faster deployment model. They know that microservice adoption is important, so the ability to create loosely coupled applications and services in very fast phases is very important. And of course, the open architecture is important to them. So all these capabilities that are on the left-hand area are things that in the telecoms as well as in the banking sector that they're already standardizing on, and they recognize that will have value around delivering the speed and efficiency they're trying to gain through application containerization. So I think speed and agility is important, but what are the use cases that we're finding in the telecoms and the banking sector? In the banking sector, for example, we know that the majority of banks have actually made a lot of investments in proof of concept work to try and see how can they leverage enterprise application containerization to drive value. So we know most of the banks on this slide are definitely doing some proof of concept, and some have actually moved to beginning to deploy complete solutions leveraging enterprise application containerization infrastructure. They're leveraging Kubernetes, which is the which is a orchestration and the management platform. So they're looking to leverage that effectively. But why are they adopting them? There are a number of reasons why banks are looking to leverage enterprise containerization. The first one is around complex release process. They're trying to improve on complex release process that they have. They're trying to scale the infrastructure to deliver the kind of growth and velocity they want around the business. They're trying to effectively have move away from historic monolithic infrastructure. They want to modernize. They are often looking to put together unveiling new technologies and new solutions, leveraging those kind of faster flow type solutions. So these are some of the pre-adoption patterns that we're finding in the banking sector. And the value they're looking to achieve from those kind of adoption patterns is really around these six things here: growth and increasing velocity, better capacity planning, improve market time from months to weeks, and of course, better customer experience. It's one thing to say to customers that yes, we're going to launch an application, but if it's taking you 2 months to launch the application and the application is falling over because it's not been well put together, then you're not getting the value you need. So Kubernetes and enterprise containerization really tries to ensure that you get this kind of value going forward in banking. The same thing applies as well in the telecom sector. The telecom are also looking to leverage Kubernetes, especially through the open network foundation solutions that we have there. We know most of the big players, both here, Huawei, have actually started to look at how do they look at the applications that they currently run on physical hardware. How do they enable that through cloud network functions? So how can they take cloud network functions and deploy those on software rather than on physical hosted infrastructure hardware? So that's all happening now. And they actually are kind of doing this across the cost. They recognize that they need to efficiently operate better, but also to get the value out of their current investments in infrastructure. It's really very important for them to do that. And they too have identified a number of reasons why they're beginning to adopt Kubernetes and enterprise containerization. I think the 5G rollout is one element of that. Applications now really massive value compared to what they were in 3G, 4G times. So the fact that you can download 10 gigabytes worth of data from mobile devices has enabled those mobile devices to become a central applications platform. And how do you deliver those applications more effectively? You need a robust enterprise containerization plan to do that. And if you look at some of the other adoption models, the reason why they adopted is change from hardware provisioning to open source software-based solution, increase efficiency and utilization of cloud infrastructure. They need to have lightweight, maybe high availability and secure deployments. And those are good reasons to really deploy to begin to look at containerization in telecom. And we know that a number of the features when we started, and a number of foundations have actually built a number of what we call typically software that are driven on mobile applications. Software that are driven on hardware and now effectively driven purely as a software platform. Okay. But let's just spend a little bit of time because I'm looking at the time we're running a little bit behind now. If we look at enterprise containerization platform, there are three leading containerization platforms in the market: Docker, Red Hat, and Rancher Labs. And basically, from our own research, we know that all these three solutions are effectively well supported in the industry. Rancher, we're very keen on Rancher because we know that the deployment notebook for Rancher is much easier at the time scale. So 3 hours is what it takes to deploy a Rancher solution compared to a week, which is what happens with OpenShift. And of course, the versions of which you could deploy includes having a mixed environment, having it as a desktop, or having it as an enterprise deployment. So really, those solutions are there. The market's evolving to them. We know the customers in the banking sector are looking to get a Rancher Labs, and I think in the telecom sector, OpenShift is the way that many of them are going. And there's value in all this technology. There's value in investigating and making a decision about which platform to use. And it's important that you take some of these factors that we got here on board. So how do you adopt Kubernetes? How do you adopt an enterprise application containerization within your environment? You need a strategy. That strategy needs to be very robust. You need to have in place really a number of people perspectives that you need to look at. You need to look at the challenges perspective. What are the challenges you're looking to address? Are you looking to build that consistent reliable experience for customers?
Are you looking to modernize your infrastructure? Or are you looking to kind of scale your infrastructure in a way that you can't do by preparing hardware? Those are use cases that you really identify clearly towards kind of implementing that's kind of containerization. So challenges perspective is important. Define the challenges, identify the capabilities you're looking to stand up from addressing those challenges. Are you fixing those challenges? Are you going to get a real value in terms of your business? So, for example, if you deliver consistent and reliable experience for customers, does that mean that the CRM solution, the customer portfolio products, and product pricing can benefit from product cost optimization? Those are kind of competitions that need to be, those are some of the strategic plans that we need, strategic ideas that we need to kind of think about. So capabilities and perspective is very important. We need to also deliver a services perspective. So in your strategy plan, you need what services are you going to be standing up from addressing this benefit of containerization, and of course, what are the financial benefits that you gain if you deploy the solution? If they deploy Kubernetes within your organization, what kind of advantage will you gain? That one is it, and increasing customer value, the new revenue sources you're generating, and you delivering cost reduction in your operation. It's important to define a strategy. Without a strategy, you really cannot define how you would adopt Kubernetes in a very effective manner. And that strategy will drive how you go together your proof of concept phase, how you go about defining how you measure the value, and how you then go about deploying what you're calling your enterprise containerization infrastructure. Those are things that need to really be brought together. So strategy is very important for adoption.
Jide's done a very good job. Thanks, Jide, for that information you've given us. So I'll just bring us straight into Rancher. If I could just really start by saying this has all started off in IT. IT is continuously evolving, okay? So we've gone from physical machines to virtual machines. Now we are at containers, okay? Kubernetes allows you to manage containers properly because containers you can run containers really quickly, but then managing quite a few containers is a lot more challenging. So you now have solutions like Kubernetes that allows you to manage all your containers in a more structured manner. And then you have Rancher that sits on top of that, that gives you a nice GUI that makes it easier because to be honest, a lot of the Kubernetes cluster functions are done at the command line level using a kubectl, KUBECTL or kube control. But Rancher just makes a lot of this easier. All right, so how to install Rancher? There are three main ways that it can be done. You can go and Google and download a Docker image and just spin up Rancher. You'll come up in a couple of minutes, figure it, and you can start adding machines to your cluster. Then you've got the Rancher's Kubernetes engine, which is RKE, and is basically the production level Kubernetes. So the Rancher server allows you to run a Docker container of Rancher. That is just a single container, and it is sitting outside of the Kubernetes cluster. All right. This second option, RKE, you basically install Rancher within the Kubernetes cluster, and then Rancher makes use of Kubernetes functions like scalability and availability and assigning resources and stuff like that. Okay, this is what we're going to be looking at today. And then you've got this K3S, which is basically lightweight Kubernetes. It's actually quite good. It's just a smaller binary. Apparently, it's about 50 meg, and you can download it. And it's basically being targeted at Internet of Things. Like you can run it on IoT sensors. It is that small. So you can basically have a Kubernetes cluster that orchestrates your workloads, and it's really small. Okay, so let's log in now to Rancher. So yeah, can someone mute? Can you mute your mic? I can hear some movements in the background. Okay, I've logged in. So what I'm going to do, I'm just going to try and go through this as quickly as possible. I would like to actually show you, I will basically be showing you, I want to try and quickly move to showing you some examples of how straightforward this is. And when I say straightforward, you must understand that any level of IT does require some knowledge. So some things will work first off, some things you have to troubleshoot. So also knowing how to troubleshoot is really a good thing. Okay, so when you log in, you're basically brought to this cluster page. This page, you can add clusters from here, or you can basically import. You can run Kubernetes at the CLI level and then import them into this space. So what I've basically done here is I created a Kubernetes cluster at the CLI level using RKE, they have a binary. And then I installed Rancher in that cluster, and then I'm able to access it here, okay? So let me start off by just showing you the different kinds of clusters you can add. So you could have, you can have existing nodes that you can now want to make into a Kubernetes cluster. You can import an existing cluster, which will basically be an RKE or K3S. And then you can use any of these hosted application, hosted solutions, I beg your pardon, on Amazon, Azure, and so forth. And there are two different ones online. So with RKE and new nodes in an infrastructure provider, basically means you have more control. If you use one of these hosted Kubernetes options, you will not have access to a lot of things. So I believe you won't have access to the control plane. You'll see your worker node. You can schedule workloads and stuff like that. All right, so that is basically how you add a cluster. So I just want to take you through the top bit here. Everything that happens here is cluster wide. All right, once you go into a cluster, everything is specific to that cluster. All right, so we can actually launch multi-cluster applications. Kubernetes, to install applications in Kubernetes, we use Helm charts, okay? And what Rancher has managed to do is a very good job of just making Helm charts a lot easier, because Helm charts basically are YAML files, and YAML files just have your declarative configuration, and you apply that, and then Kubernetes goes off to give you your desired configuration. So there are catalogs where you can basically, where all these Helm charts are. I won't select any of these ones, but I just want to show you an example of being able to launch an application. So you just click on launch. What's a popular application? MariaDB. Let's see, MariaDB is here. So we can come, click on MariaDB here, read the description, configuration, and stuff like that, and go ahead and launch this application. And what it will do, it will allow us to select which clusters we want to deploy this application in. So that should be somewhere up here. We add the target projects within a cluster, and then we can deploy that. So that's basically applications. Moving along, there are just some basic settings that can be run. These are settings basically for the Rancher user interface. I won't go into too much detail, but you've got advanced settings and you've got feature flags that you can turn on and off. All right, security, you can create users, groups, roles. Pod, you can create pod security policies. Currently, I believe there are only two, which are restricted and unrestricted, but you can add a policy if you want. And then authentication, we can use all these methods. Popular ones are, well, Active Directory. I believe there should be LDAP somewhere here, Open LDAP here as well. So you can basically authenticate from Rancher to your Active Directory for single sign-on. We looked at catalogs earlier. These drivers are drivers. So this is Alibaba. So you basically need drivers to be able to interact with these clusters. And these are the drivers for those. You can create global DNS entries. You can have global external DNS providers. And you can create RKE templates. So you can create a template of a cluster you want and what it should have, the type of networking and different things like that. And then you can apply that template to a cluster. All right, so that's just a brief overview. Forgive me for moving quickly. I'm going to go into the cluster very quickly just to give you an overview. Once you go in, that menu changes. You now have a cluster view. This is showing us a summary. You can see we've got 20 CPU, about 62.7 gig of memory. And we have pods. These pods are basically containers. So the way Docker has created it, you have containers. And what Kubernetes does is Kubernetes has pods, and those pods contain containers. Sorry for using the same word. But basically, pods encapsulate containers in Kubernetes. They're referred to as containers. You can launch, I was talking about kubectl, so you can launch kubectl from here. So if I just show you quickly, there are nodes in here. We've got 3 nodes. We've got a controller node and 2 worker nodes. But if I come back here and I launch kubectl, it will take me onto a command line interface. And I can basically get that same information I just showed you from the command line. You can see the hosts, they're ready, they're working. So like I said, Rancher just makes it easier for you to administer a Kubernetes cluster. You could basically administer a Kubernetes cluster without using Rancher. But I think we're all a bit used to GUI interfaces. Kubeconfig file. This file contains the configuration for the cluster. All right. So if you're basically trying to set this up, what you want to do is have a management server. You copy all these config files, and you can then sit on one system and manage all the clusters that you need. Okay, I briefly touched on nodes. You have basically a controller node and worker nodes. The controller node runs the database and runs the control plane. If I just bring you back here to this visual, it looks better. You can see the database here, it's working okay. The controller manager, the scheduler, the schedules, and then all the nodes. So that gives you information. So this just shows the nodes and what they can do. You can drill down and have a look at them, okay? Storage. You basically, if you want to be able to, you have to assign storage to containers. And some of the storage as well needs to be kept. Like if you have a database, you want to make sure you've retained that information. So to explain it this way, a container makes a persistent volume claim to a storage class, which has been predefined, and that allows for that container to be dynamically provisioned storage. Okay, so that's what a storage class does. A storage class basically defines parameters for systems that need to connect. So if you look at some of the parameters here, it just tells you number of replicas and stuff like that. You can customize it. So it's just an easier way. If you didn't have a storage class, you would have to basically go and statically provision persistent volumes for each container created. So these are some PVs. Some persistent volumes have been created, and you can see they have been claimed by containers. That's why you got the PVC. So you have a persistent volume claim, talk to a storage class, which assigns a persistent volume, okay? Now, Kubernetes basically has namespaces for you to be able to, if you like, logically separate. They're like logical clusters. You can logically separate your data. Rancher has gone a step further by putting projects on top of that, so you can actually use authentication, and you can use RBAC, remote based access control, to allow who gains access to which namespaces. So it's just a neater way to arrange. So this is, I created this project called Customer One, and it has all these namespaces. If you're using Kubernetes directly, you will not, there is no concept of projects. These guys have just put this in, it actually makes sense. So for example, you have 10 customers, you give them all a project, you put all their namespaces with all their workloads inside that project, okay? Every cluster comes with a default project and a system project. This system project basically runs all the system functions, okay? And just to be very clear, everything that runs here is a container. The whole concept of a container, just think of a container like an application. If you just want to run a web server, you don't really need to go and build an entire virtual machine that consumes so many resources just so you can run a web service. A container allows you to just run that web service, okay? So these are a few of the system containers. This is the rancher that we're currently looking at. We are on this rancher. And if I just click down here, for example, you can see it's been created with 3 containers. So if you had 3 nodes, it would deploy 1 to each node. So the orchestration and stuff like that is quite automatic. Okay, so that was the system. So I'm just going to quickly take you now into the customer namespace. You can also use this left-hand bit to just navigate quickly to where you need to go. All right, so I am now in the customer 1 project that I showed you earlier. These are all the namespaces I've defined in this project. And the resources are defined on the workloads. Okay, so I basically deployed a couple of workloads. This is Moodle, it's a learning management system. I beg your pardon, let's just have a look at this. Okay, so this is, that was just the system's quite busy, it's doing a few things. So this is a learning management system, all right, that is running as a container. Another example is, this is human resource manager, yeah? It's running as a container. These are all containers. You can see me clicking on the link. This is WordPress. Okay, so these are all individual containers just running all their workloads basically separately. And you can also click in, for example, into a container. You can take a look at the metrics. You can see how it's working. Because there are things, for example, the granularity of Kubernetes is actually quite impressive. We can actually monitor this utilization, and then we can set the CPU and memory utilization that this container is allowed to use. It tells you what node it's running on, it gives you the IP address, it tells you what Docker image. These are all Docker images. Containers basically run Docker images. So when you create a container, you have to point to a Docker image, it will go and create it. If there are any ports that need opening, you need to do all of that. You can go straight to the shell of the container. You can look at the logs. This is always a very good one to see what's happening. This is just giving you the basic HTTP information. It's just waiting for a request. And also what is quite good, you can actually, everything basically, like I said, in Kubernetes is a YAML. Rancher has, like I said, done a very good job of just making it all nice and friendly, because this is what the YAML looks like. They've added a few of their own things, but this is, you basically declare what you want, and the cluster then gives you what you want. So if you look, you can see the password and stuff like that, all the configuration information for that container. Okay, so let me just quickly, okay, so you can also have what this is called HPA, horizontal port auto scaling. So what is that? You can automatically scale pods based on utilization. So I could say start off with 2 containers, and if the CPU exceeds maybe 40%, then spin me up another 5 containers. So I can give a min from, like, say 2 to 10, and based on utilization, those containers will get spun up automatically. It's used, for example, a lot of companies have like these Black Friday sales. So you have sometimes where there's high utilization, and this is a very good way. You could just scale up the containers to handle that workload, and then they scale down when the workload is finished. Pipelines is actually very good. I was actually trying to set up a couple. Unfortunately, they didn't work. But what you can do with pipelines is you can go to GitHub, you can upload your code, and then you can create a pipeline that allows you to pull that code down, all right, automatically. And so all you need to then do is go to GitHub, change your code, and a trigger can be set in Rancher that will then rebuild your container based on the new code. So pipelines are very useful. It's all about this continuous integration, continuous delivery, so that you can basically spin things up quicker. You can test things quicker. Yeah, if you're familiar with GitHub, you can create different branches for your different code, and then you can be your production code probably can be master. They could maybe have a test branch, and you can be running the new functionality in the test branch, testing it alongside production, making sure it works, and then spinning it up. I just quickly want to show you here. This one failed, but this has basically done three things. It's basically, first off, it's cloned GitHub, okay? Then it's built, it's basically built the image. It's gone through all these steps. This is what I asked it to do. It's pulled the Microsoft .NET image, as you can see, and then it failed at run because there's basically an error. There's an error in the YAML file I use, so I'll investigate that later. So pipelines are actually very good. Istio is a service mesh. I won't go into that. You can also create secrets. Okay, so basically secrets, username, password. You can see password, MariaDB, password, certificates. You can create certificates, and then you can have a private registry. So for example, Docker is the online registry, but you can have your own private registry, which you control yourself, and this way you define it. And then we have config. If you need to send config to workloads, you can see, if you guys are familiar, for example, with MariaDB, you database folks, you guys know you have a CNF. You can see the CNF basically defined here, all right, with a configuration for the actual container. I pretty much covered it. There is one more thing I wanted to show you. Hopefully, I can just do that quickly. We have this demo that basically shows you utilization. So if we look at this Rancher demo, we've got 2 containers. If I click on that, it's now showing you the traffic is being load balanced across 2 containers. We have 0 errors. Okay, now what I'm going to do quickly is I'm going to just spin up. I'm going to bring that up to 7, but you can see, beg your pardon, what's it saying? Excuse me. All right, this may not post run on a pod. All right, if this works before that, I can explain what's basically happening. Because what I've done is you can define a few different. You can define that the container runs as a cluster IP, which means it only runs return to the cluster. It can run on every node at a particular port. That's what I was doing now. And the reason it's failing is because there's only 1 port per node, okay? That's why it's failing. So I changed it to cluster IP. If that picks up before this goes off, you will see that it will start updating itself. Okay, so basically that's pretty much Rancher at a glance. There is a lot more you can do. You basically, like I said, can go and download it, have a quick look, and enjoy it. This is the new technology. This is the way of the future. I suggest everyone just takes a look at this. Okay, thank you. Promise I'm done. Thank you.
So thank you, Abel. Can you hear me?
Okay, Jide. Yes, I can.
Yeah. Thank you very much. That was very sweet as well, actually. Much better than the quick session we had. Thank you, everybody, for joining this webinar. Can I please ask if you have any questions? Unmute yourself and ask a question, and we'll try and answer the questions as much as possible. We've got 10 minutes for questions and answers, or any other thing you want to cover on this topic.
Yeah, so we have a question in the chat box.
Okay. From
Adewale Shotobi. He's asking, is Rancher similar to GKE?
Yes, it is, but GKE is basically your solution in the cloud. And I believe if it's GKE, if you go onto GKE, you may not have visibility of certain things in your cluster. So remember that, so look, this solution exists online. You can use it, that's no problem. But online basically comes with a cost. If you're just trying to run your applications locally, you can basically build this. We basically built quite a few clusters that we are managing ourselves, and it all works okay. So you can use, this is very similar to GKE, but I bet you if you use GKE, you will not see the control plane. You will only see your worker nodes, which means you have no control over the control plane. So it's a hosted application, a hosted solution, basically, yes.
Yeah, I think, if you want to just add to that, I think if you think about what the typical deployment model would be, so what Rancher tries to do is to give you that kind of orchestration, the visualization sort of thing, to look at your workloads and manage your workloads. That's what it does very well. And I think that's what it's over and above better than many other solutions out there. So you can do a lot of things in command line, and Rancher does do that, to go and do that. Because it allows you to visualize your enterprise containerized infrastructure. It really gives you that kind of, overvalue over everything that is what you're doing. It gives you the tools to really manage it.
And so just to quickly add to that, if you look here, for example, you can see, you can basically, you can create your cluster in GKE and you can manage it in this Rancher UI. So you can see Google GKE is on this list. But as I mentioned earlier, it is a hosted solution. So you don't, they're doing a lot of the work for you. They're just giving you the worker nodes where you can deploy your workloads, but you can manage that GKE infrastructure from here. So this is your central, this is your central portal. So you could basically have 1,000 clusters, 100 clusters, everything sitting in here.
And you can deploy into GKE, that's correct as well. Or the other way around?
Yes, yes, you can deploy. You can basically deploy Rancher into any cluster, into any Kubernetes cluster. All right, I don't know how much time we have here, but basically I went on, like I said, this GUI is very helpful, but to be honest, you'll really be using a lot of the Kubernetes functionality. Rancher makes it easier for you to manage Kubernetes, but it is not a replacement for Kubernetes. It's an add-on. Yeah, so basically you deploy stuff using a Helm chart. So it's interesting. I just want to quickly try something if we've got enough time. I just want to take a look at something. It might be, Rancher might actually be in, because I installed it as a Helm chart. Okay, Rancher's not here. Yeah, but basically you can, Rancher, there's a Rancher Helm chart. And you just use that, and you can, once you stick that in, you've got to basically create a certificate, give it a host name, make sure the host name is reachable, and then you'll be able to get to it. Okay?
Thank you, Ebo. I don't think there's any other question. I don't think that we have any other one. Promise, do we have any other questions in the chat section?
No other questions in the chat section.
Okay. Thank you very much for attending. And just once again, we'll be sending you the slides for the slide deck for this. And we will be having some additional webinars in the future. We'll keep you posted. Have a good afternoon.
Okay. Thank you.